you hear me? Bingo? Okay, our presentation is a joint effort, and sorry which was me to it. And the whole presentation is a result of freedom to choose where we wanted to go. And I saw some billboard the other day that said, think outside, no box needed. And so that's basically what we did. And it's a result of internal collaboration with U.S. people in Europe. And it also resulted in many open doors. And we had some interesting paths. And we'll touch on those a little bit. But I'm a topic sentence guy only. When you look at a paragraph, the topic sentence basically says what the paragraph's about. And I let other people figure out what's going on. So these are the collaborators. And we got Tom Ward, I met a chance at Brookhaven National Lab, and Dr. Milchevich, I met when he was visiting University of North Dakota, Grand Forks Human Nutrition Lab. So I'm dedicating this to my father. He was a pioneer, and I don't know how I get the, let's see. Oh, it's not showing up. He was a pioneer. I was born in Dakota Territory, October 14, 1889, 131 years ago yesterday. And he was a homesteader. And you have a picture of the lower left is his homestead shack from 1912 to 1911 to 1913. And it was a drought, so he couldn't farm there, I believe. And he was quite an artist. He could just, if you look at the middle picture, he could just draw perfectly. And in no time, he was a county commissioner, and he also was a welfare board member, where the county would meet, and there were people that needed subsistence, and he never told us anything about it, but he was worked on that. Now, if we go to the next slide, now I can click. Okay. Okay, why do we analyze grid tissue for radioactive trace elements? I was in a trace element laboratory, and that's what you do. Since it goes back to 1977, which is 43 years ago, when we had a whole body counter, and the director asked me if I'd come and run it. And we've been looking at trace elements from these radioactive traces. If you look at this, if you can see the next, the shielding had some recycled lead inside, and this recycled lead had radium-226 in it. So if we can go to the next one, there was a background. What happened is the background would be high in the morning and would be low in the afternoon because we'd be going in and out. There wasn't any ventilation in the steel room. So we put that in. Next one, please. There's a radium-226 gamma ray spectrum. Gamma rays are like X-rays; they're high energy. And if you look on the horizontal axis, that's the energy. And if you go, and now this was during the time when renal and lung cancer was a real concern. We'll get to that in a little bit. Now, environmental radon is a noble gas, and it's the heaviest noble gas. Helium is a noble gas with only 2 electrons. Radon has 86. If you think about it, when the teenagers are too easier to take care of 2 teenagers than 86 of them. And that's why radon gets in chemical bonds through anyway, electrons, it gets through, that's why electrofields around it. But in the next part, it turns out that your tabletops have green in them, and they're granite, and has uranium in it, radium, and that gives you radon. Next slide, please. Now, Now, here's the main decay scheme. It starts with U238, ends up as stable lead. If we have it again here, notice that they're all heavy metals except for radon, which is a noble gas, and that again doesn't have to. And it can be in the air and it can go anywhere in place it wants to. Now it turns out that humans are kind of like charcoal canisters, and when you breathe in radon, it can stay in you for a while and then it goes out. So what happened is, this is about 1980 when the U.S. boycotted the Russian Olympics because the Russians were involved in Afghanistan. He's right in there now. And so one of the colleagues was studying exercise physiology, and he got somebody like cyclists to come visit with us. And we were, at that time, we heard people had said that that potassium redistributed to exercise in cross-country athletes, so runners. So what we did is we looked at the muscle, the thigh, and parts of the abdomen of these cyclists after they go for 65-mile runs, and we noticed that we can't see them very well, but we noticed that there were some extra peaks in there, and these peaks, one of them occurred right in the potassium one. So these people have still increased counts in the potassium. If you look at those peaks potassium redistribution. Now in the body, you notice the potassium can't move around. If you have 1% movement. Next slide, please. Next one. Okay, they're the cyclists. They go for 65-mile runs in North Dakota. There's a guy, Andy Houston, was on the 7-Eleven Tour de France team, and he would ask him how could he climb mountains so well. He said, I was used to traveling against the North Dakota winds. Now what we're doing is I was running the radon monitoring facility, and we looked at that through the season. We noticed that the top right graph is for women. That's basically the bismuth 214, which is a prominent isotope, gamma-emitting isotope of radon. So that basically points out where the radon is. Notice with women, there's a pretty strong correlation. With men, it's not that strong. The background of the whole body counter varied with the same season, as did the radon in the homes, and many thousand measurements there. Next, the next part, please. Okay, this is the whole body counter. That what it does is these detectors on the top, they're like X-ray detectors. They turn these like X-rays, gamma rays coming out of the body, and they turn them into electronic pulses, and the electronic pulses then can tell you how much potassium is in the people. And each isotope has its own characteristic spectrum. Next slide, please. Okay, so now Fiona Hunt was studying smokers, and she found that human semen contained polonium-210. Now, polonium-210 is a daughter of lead-210 through bismuth-210. So that's a radioactive daughter of radon. So we found, we did some measurements. We found polonium-210 in hair, and we also found lead-210 in hair. And we found that the lead-210 correlated strongly with bedroom radon. And if you notice a couple of references there, and we look at those peaks, the tallest one is on the right is polonium-210, and that's their alpha particles coming out. Now I notice there's a 208 and 209. Back in years ago, you could buy radioactive tracers, so you could put that in your sample, and you know how much you could calibrate how much you got. So notice that there's a strong polonium-210 peak. This is in hair of so many subjects. Next slide, please. Now, we demonstrated that the body can, I went to a room that had high radon in it, and then I had a measurement, and then what we did is I had breakfast, I had some radon-free air, breathed in, and we were able to flush out the radon. And notice the graph the blue graph, basically, one of them, the one with the sharp peak over the mouth, didn't have a mask on. The other, the blue group had a mask on. Notice there's a big bump right over the omentum, which is the stomach region. So we noticed that radon is highly mobile in the body, and goes in and out. But we found that there was plutonium-210, which is one of his daughters, and lead-210 in hair. That motivated us to attempt to analyze brain regions for radon progeny. So the next one, please. So what happened is I noticed I said there are some open doors. I made a 1-800 call to the Ramsey Alzheimer's Research and Treatment Center and was able to talk to William Fry. And I told him my name was Lykken. He says, well, I know David Lykken. I published with him. David Lykken was the guy that known for lie detector tests and twin studies at the University of Minnesota. So that was the middle. And so then what we did is we set up a study where we analyzed the protein, the lipid, and we looked at different parts of the brain, the gray and the white matter. And notice the first under control, there's just a little bit of activity. But when you go to Alzheimer's disease, the protein has a lot of, it's high bismuth, polonium, which again, bismuth, which are daughters of lead-210. Okay, so notice then that smokers, we know that there's polonium-210 in smokers. Notice that there'd be a lot of the smokers, you'd expect that. So these are some plots we did, and we published this in 2001. Anyway, notice then that different lobes, we have the temporal lobe, and notice again that we have just a little bit in the control brains. All these brains, everything was, all the data were given on them. The study was done through an institute review board, so we didn't know anything about the subject except what they died of and what they had. So notice again that Alzheimer's, you've got this in a protein, and in Parkinson's it's in the lipid. In smokers, you still have some. So what we say is it's important to note that the two betas produced in the decay of lead-210. This was published in 1949, a number of years ago, by Campbell and Novak. It's in the Proceedings of Experimental Biology and Medicine. And notice then that polonium-210, well, the two betas that come from the decay of lead-210 can actually damage the astrocytes. And just recently, damaged astrocytes have been associated with Alzheimer's disease. Can I have the next one, please? And here we did an 86-year-old lady that suffered from Alzheimer's disease, and one of our doctor friends actually analyzed, took the brain apart, and we looked at the different parts, and noticed the hippocampus and the amygdala have high polonium-210 and bismuth-210. And so the points at the amygdala and the hippocampus are one's with emotion and one's with memory. And so this is the first report that in radon progeny can reach dangerous levels of radiation in the brain. So that was published a number of years ago. Next one, please. Okay, next slide. Okay. Now, notice that you've seen a lot of chimney smoking. And Tom Ward pointed out that the major contributor to lead-210 in air is from the combustion of coal, because coal has lignite in it, and that lignite has uranium in it. Coal has uranium in it, and as we saw before, the uranium decay scheme, there's lead-210. And so it turns out that these lead-210 decays into polonium-210, they're aerosols, and they can be incorporated into ultrafine products, which are produced during combustion. Now, these ultrafine particles are particular manner of scale size, they're less than a tenth of a micrometer up to 100. Higher. So we notice then that the equilibrium incorporated in this ultrafine problem, it turns out that further you have internal combustion immediately produce nanoproducts, and these they again range in the scale from 0.1 micrometers to 100 nanometers in diameter. So next slide, please. So now Charles has been working with green certified homes, and it turns out that the particulate matter have less than a diameter of 2.5 microns, which is about 3% the size of a human hair. If you look to the right, then we see that we see relative size. They're pretty small. Your common written is, could go back, please. Your common written is P2.5, and so notice then that they can be breathed into they can be absorbed in the lung and distributed by the body through the bloodstream. And they actually travel up the olfactory nerve directly into the brain, and we notice that lead-210 and plutonium-210 are equally distributed with short environmental lifetime of 4.8 days. They're not equal at any time, but they've been absorbed into the body. Now what we wanted to do is we wanted to get a diesel engine, and we just captured some of the exhaust, and we had two filters. We had a 30 nanometer filter and a 0.8 micron filter, and we sampled the air. If you notice, on the lower left, we've got pictures of the samples after exposure. Okay, now, if you look at the size distribution, the first, on the left, there's in your exhaust particulate matter, you got this from a diesel engine, you have quite a range of sizes. Now, if you look on the to the right picture on the right, we stored some of those samples you saw on the previous slide for up to 2 years, and then we stuck them in a detector that detected alpha particles. And alpha particles are just helium nuclei, and so the only helium on Earth comes from the decay of uranium. So anyway, the word helium comes from Helios, the sun, because helium was first discovered in the emission from the sun, the helium wavelengths. Now, hydrocarbon combustions uses ambient air, which contains radon, and interest legislation in using okay. So anyway, it turns out that you can breathe these in, and the automobile, we used to use lead tetraethylene for anti-nox until 1970 in the airplanes. In the gas-fired airplanes, because you get power out of it. Now, back from 1950 to 1987, 5.5 megatons of exhaust lead was emitted in the U.S. And then we went to manganese anti-knock compound. Next one, please.
Sorry to interrupt you. Could you please put conclusions?
Okay, well, wrap it up quick here. So we find that if you look at the lead-210 that comes out of these out of the diesel engines, and if you look at 0.1, you look at the disintegration per second per gram, and that gets deposited in the brain, and it turns out that lead-210 can go into the cell because as an ion, it can mimic calcium +2, and it can go in, but it can't go out. So the interesting thing, you can capture lead-210 in your brain, but it can't get out. Now, how does it get in? Turns out the blood-brain barrier keeps out most problem things, but nanoparticles can go right through the blood-brain barrier, and so can these ultrafine particles, which are nanoparticles. Okay, Next one, please. Now, we came to the conclusion that hydrocarbon combustion generates these ultrafine particles which grab up lead-210 from the air, and they can easily cross into the cellular membrane. And we demonstrated one of the previous slides that polonium-210 accumulation in the brain's highest in the amygdala and the hippocampus. And then one of the things we'll note with Alzheimer's, they're impaired nose smell test may indicate this limbic dementia movement. Okay, so perhaps Alzheimer's disease may be a exceptional case of protein misfolding. That's been discussed a lot recently. And notice then that protein misfolding is probably caused by calcium imbalance. So it turns out that the most radiosensitive part of the brain is the neuron. Notice the yellow, notice that you've got lead-210 in the bottom lower left. It's a beta particle, goes to beta-210, and this beta particle is polonium-210. Polonium-210 sends out this cannonball, the alpha particle. So it turns out that perhaps the astrocytes are damaged by the beta particles, and almost not to mention what the primitives do, and the whole problem may resolve in Alzheimer's. So that if you want to have any medical questions, Dr. Monchovich, she's an MD, PhD, physiologist, combustion products on board, and air quality John Trout. Okay, well.